Hi everyone! Today let's talk about session 11.3, Boolean algebra. A Boolean algebra consists of a set S containing distinct elements 0 and 1, binary operators plus and multiplications on S, and a unary operator prime on S, thus satisfying the following laws. First, we have the associative laws, x plus y, and then plus z is the same as we add the y and z, and then we add the x in front. And then multiplication is also associative. We can multiply x and y first, and then we multiply the z on the right, or we can multiply the y and z, and then multiply the x on the left. Okay, and then for the addition and multiplication, so this is just simple addition and multiplication. They're not like the addition of numbers, multiplication of numbers. Those are just some symbol. Okay, so keep in mind. And we have the commutative laws. X plus b equals x plus y equals y plus x. X times y equals y times x. Okay, and we also have the distributive law, x times y plus z equals x times y plus x times z. X plus y z is also equals x plus y times x plus z. I know. This might look different than what we had before, because if you just think of this is like addition and multiplication of numbers, then you say, how would this possible? Okay, so my big suggestion is when you think of this Boolean algebra operators, think about set. So plus is like union, and then multiplication is like intersection. Okay, then you can think of what is this guy. You can try to use the distributive law on the right hand side. You can have like x times, so this is like x times x plus x times z plus y times x plus y times z, right? And then if you think about intersection, x intercept x is x, right? And then you have or x intercept z, or y, x intercept y, or y z. But look at all these. You know, x intercept z is a subset of x. X intercept y is a subset of x. So that's why all of these, when you take union, well, which one is the biggest set, that's the because the relation of them are subsets, so the union of a subset and a set is the bigger set. So that's why this is x plus y z, so you will get the same results. So here, keep in mind, we use the properties of like intersections and unions. So they are not like addition and multiplication of numbers. So they're different. We just use the addition and multiplication symbol to denote. But when you think of it, it's better to think of it using the set, intersection, and unions. Okay? And then we have the identity laws. X plus 0 is x. X times 1 is x. We can use set to think about it. For set, you can think of the 0 is like the empty set. The 1 is like the universal set. Then any set union the empty set is that set, right? Any set intersect the universal set is that set. Okay, this is what it is about. And then next we have the complement laws. X plus its complement is 1. X times its complement is 0. Ooh, why is that? You think about the set. A union A complement is the universal set. A interset A complement is empty set. Right? So we can use the set notation can help us to understand these operations. Alright, so if B is a Boolean algebra, then we write B is the orders. We use parentheses to denote as, comma, with the operators plus multiplication and the complement and the 0 and 1. So far, so good, everybody. Okay, next. Example by the theorems, our Z2. So Z2 is the set of the elements 0, 1, and then we have the or and not, and 0, 1 is the Boolean algebra. Okay, and operators plus multiply and complements, they are or and not respectively. Okay. So as is the standard custom, we will usually abbreviate A times B as AB. We also assume that multiplication is evaluated before the plus. This allows us to eliminate some parentheses. Okay, let's look at some example. S equals the set of 1, 2, 4, 8. Define plus and multiply as x plus y equals the least common multiple of xy. X times y is the greatest common divisors of xy. Define x prime, the complement is 8 over x. Show that s plus dot prime 1, 8 is not a Boolean algebra. Well, no matter if we want to show it Boolean algebra or not a Boolean algebra, we want to go through the laws. We want to show if it follows all the laws, then we can show it is a Boolean algebra. If it does not follow a law, a specific law, then we can say it's not a Boolean algebra if it violates one of the laws. Okay? So let's look at the laws again. What are these? First, we want to show both operators are associative, commutative, and then distributive. We have the identity laws and the complement laws. Okay, so 5 laws. Keep those in mind. Let's see. Let's check. First is associative law. Oops. Okay, so what is associative law? We want to have x plus y plus z equals x plus y plus z. But what is this? Well, this is the same. This guy is the LCM of x and the LCM of y and z. Well, this is the same as the LCM of all 3 of them. Right, the least common multiple of all 3 of them. So that's why it's also the LCM of x and y, and then we can do LCM of xy and then the z. So this is the right hand side. So far so good. Similarly with the GCD. So GCD, because x times y times z, we can consider is the GCD of all 3 of them. Okay, so that's why the order doesn't matter. We can find the GCD of the first 2, and then find the GCD of yeah, we can find the GCD of this 2, and then we find the GCD of those 2 numbers, and they're the same. Okay, or find the GCD of this guy and then find the GCD of those 2 numbers, they're the same. Okay, so that's associative law. So B is the commutative law. Well, commutative law, x plus y is the LCM xy. Well, LCM of xy is the LCM of yx. Yeah, so that's why here we have the same. Okay, so least common multiple of 2 numbers, no matter which order. is still the same. So, and also greatest common divisor also works the same way. So this is GCD of xy is the same as GCD of yx. So that's why we have the commutative laws. And for C, for the distributive law, this is quite complicated, and let's not show it here because I've shown you in our homework solution. So we show in the homework solution. Okay, I have proved to you that distributive law actually holds. Okay, so in this example, associative law holds, commutative law holds, distributive law also holds. And I have write down the complete proof in your homework solution. So you have a homework similar to this problem. Try to work on it first, and then you can look at the homework solution. Okay? And then let's go ahead. D is the identity law. So identity law. Okay, so what is that? We want to check whether x plus 0 is x. Okay, what does that mean? X plus 0, well, this guy plus is the least common multiple, but the 0 is like the 1, right? And then the 1 represents the 8. So LCM of x and 1 is x. Okay, and how about x times 1 is x? Well, this is the GCD of x and 8. Well, this of course is 8 because you can see 8 in this case is all of the 1, 2, 4 divides 8. Okay, so far so good, everybody. So this holds. Okay, so because we only have 5 laws total and all of those 4 holds, maybe you should know that this complement law must fail. Okay, so complement laws. What do we want to check? We want to check whether x plus x prime is 1 and whether x times x prime is 0. So what do we want to check here? We want to check whether the LCM of x, what's the complement? Complement is defined to be 8 over x. Is this guy equals 1 corresponds to 0? 1 corresponds to 8. So far so good? Okay, let's see. Is that true? Wow, no, this is false. Why? You can pick x equals 2. Then LCM of 2, 8 divided by 2 is 4. LCM of 2 and 4 is 2, which is, LCM of 2 and 4 is 4, which is not 8. So that's why it is false. Okay, and also we can also show it here, the GCD of x, 8 over x equals 1. We want to check that, but we can also pick x equals 2. Then the GCD of 2 and 4 is 2, which is not 1. So now we have shown that it failed the complement laws. Okay, so we failed here. So that's why it's not a Boolean algebra. So far so good, everybody? Alright, let's continue. Okay, so example. Let U be a universal set and let S be the power set of U. We define the following operators. Plus is like the union, intersection is the multiplication is the intersection, prime is the complement, and so this is the set operation, right? And this set operation is actually a Boolean algebra. the empty set plays a role of 0 and the universal set U plays a role of 1. Because remember the set operations, we talk about all of those laws. Okay, so those are exactly the laws of Boolean algebra. Next theorem. In a Boolean algebra, the elements x prime is unique. Specifically, if x plus y equals 1 and x times y is 0, then y equals the complement. Oh, okay. So keep that in mind. So if you think about the sets, is like, oh, A, remember A union A complement is the universal set, and A intersect the A complement is empty. And because this definition is unique, so any set satisfy this requirement, it must be the complement. Okay, so in a Boolean algebra, we call this element x prime the complement of x. Because it's really, we can use analogy of the set complement, okay, to understand it. Okay, so more theorem. We have more laws, okay, so here are the properties. We can also use set to understand. First law, x plus x is x. Think about a set. A union A is A, right? X times x is x, so A intersect A is A. So far, so good, everybody? Yeah, so this is the difference than working with numbers. So this is the difference than working with numbers. So number addition, multiplication. Because for numbers, x plus x is 2x. But no, in this case, it's just x. And x times x is x squared, but in this case, it's x. So that's why they are different. Don't get confused of them. So that's why even though we use the notation plus and multiply, when you think of it, don't think of it as plus or multiply. Think about the sets. Think about intersection and union. Okay, everybody? And then we have the bound laws. X plus 1 is 1. Well, use sets is A union U is U. And then x times 0 is 0. So A intersects empty sets is empty set. Okay. Oops. Okay, let's continue. Absorption law. X plus xy is x. Okay, so why is that? Because xy is if we think of set, right? We have A union A and B is A. Why? Because A and B is a subset of A. That's why the union, you're gonna pick the bigger set, so that's A. And then next, A and A union B, because A is a subset. When you take intersections, you pick the subset. So far, so good, everybody? So use set to help us to understand. And then we have the involution law. X prime is x. So complement is A. Okay? 0, 1 law, 0 complement, empty set complement is universal set complement is empty set. And then the Morgan's law for Boolean algebra, so we have seen this before, right? This is A or B complement, is A complement. It flipped the or become and. Okay, and A and B complement. We have A complement, B complement. It flipped the and become or. So far, so good, everybody? So use the set to help us to understand those laws. Okay, next. Definition. The dual of the statements involving Boolean expression is obtained by replacing 0 by 1, 1 by 0, plus by multiply, and multiply by plus. Example, find the dual of the following statements. So here, okay, now let's see. So we have plus, when we see plus, change it to multiply. So it becomes x times y prime. And it is multiplied, change it to plus. So x prime plus y prime. Okay? And then all the rest stay the same. Next, you see, we have plus here. So we say if x times y equals x times z and x prime times y equals x prime times z, then y equals z, right? So we only search for the times and plus, 0, and 1, okay? So here, what do we change? X equals 0. So search the 0 if and only if y equals. So there is a dot there, and there's a plus here, there's a dot here. Okay, so how do we change? X equals 1 if and only if y equals x. It was times, now it become plus, but you gotta be careful because there is a parentheses between them. Okay, so you're gonna calculate these guys first because we calculate this guy and calculate this guy and then we add. This is the order. Your order must preserve. Okay, and then the plus become multiply, and then here x prime plus y. Okay, so let me emphasize here. So parentheses, so be careful with the order. Okay, sometimes we need to include parentheses. So far, so good, everybody. Oh, and we forgot for all y there. We also need to mention it, right? So for all y. Okay, so that is the rule of the following statements. And it's quite useful because there is a fact, the rule of a theorem about Boolean algebra is also a theorem. So which means if you show this guy is true, then this guy are also true. Okay, everybody? So they are equivalent. Okay, so that is about sessions 11.3. Please go ahead and complete your homework. When you have questions, feel free to ask me. Bye!